Hello and welcome to the next lecture on engineering mechanics. So in the last lecture what we have seen is about Lami's theorem, and we have solved some numericals. Then we have solved some numericals from resolution of forces, and then we have also seen some gate question, one gate question. And in today's lecture the topic is, the next one is Varignon's theorem. So Varignon's theorem tells, also it is the principle of moments. Okay, so what Varignon's theorem? Varignon's theorem, I'm writing Varignon's theorem tells us about the location of our resultant. It means so far we have found the resultant and at what angle the resultant was acting, but we don't know the location of the resultant. So from Varignon's theorem we can find the location at which the resultant will be acting. So Varignon's theorem says that summation of all the moments produced by a system of forces will be equal to the summation of the moment produced by its resultant. That means, suppose there are so many forces and all the forces together is making some is giving some resultant. These forces are replaced by a resultant, then the moment produced by this resultant will be equal to the moment produced by all the forces. Okay, so moment is something which is related with distance. Now we can find the distance of the resultant with Varignon's theorem. So it states the algebraic sum of moments produced by all the forces is equal to the moment produced by their resultant about the same point. First of all, we need to know about what is moment. Moment is force into perpendicular distance. Don't make a mistake in here. That means if you just don't understand what is exactly moment is, then the next concepts, overall whatever you learn in our strength of materials or the later chapters, the subjects, it will be a totally waste, because moment, from moment bending moment will come, from bending moment the total shear force, strength of materials, the deflection, all the subjects, all the structural analysis, these all are connected. So that is why you first understand about moment. See, if this is a door, it is a door, and at this portion it is hinged. Okay, and we need to open that door. To open that door we are giving a force in here, and the distance between the force and the hinge, this part is hinged and this part we can open. So this force is F1 and this distance is D1. I'm writing it. Suppose this is D1. Okay. In this case, more force will be required. Why? Because distance is small. You can understand that if I push here, then force 2. This, if I push this door at this portion, then it will be lot easier to open this door. Why? Force is same, force is a little low than this force. This force is bigger and this force is smaller. Then how we can open that door? Because the distance is increasing. Distance is increasing means moment is increasing. So some moment is required to open this door, and that moment is M. M is the moment. Okay. Moment is force into perpendicular distance. So that is force into distance perpendicular. That means at 90 degrees. So in the first case, this one is equal to F1 into D1. Okay, but distance is small, the distance D1 is low, this D1 is small, then force has got to be more to produce this moment of M in here. In second case, what we can do, M is equal to F2 into D2. In this case, the distance is more, the distance is increasing. If the distance increases, then less force will be required. Okay, so that is why force is less in this case and more in this case. But both of them are producing same moment, and some moment was required to open this door. Now we can open this door easily by pushing in this position, not in this position. So that is why moment is the product of force into distance, and that distance should be perpendicular distance. Again, is understand with this. Suppose this is a beam, and at this portion it is hinged. Okay. Now we need to rotate the beam with, at this portion it is free, and about this portion it can rotate. It can rotate like that. If it wants to rotate like that with some acceleration, with some constant acceleration, then we can put a force in here. If we put a force in here, then this distance is D1, this is F1. So F1 has got to be more to produce the moment M, because the distance is smaller. Where if I put the force in here, F2, and this one is D2, then D2 is much more, then F2 has got to be small. It means with small amount of force we can rotate these things. So we can rotate this thing with small amount of force because distance is increasing. So moment is actually product of force and perpendicular distance. Okay, so moment is actually this one. Now next one is I am going to transfer some force. Okay, you understood about moment is this one. I am going to transfer some force from one point to another point. See what is happening. If this is one body and I am giving some force in this portion, okay, this is the line of line of action of this force F. This is the force F. I can replace this force anywhere along the line of action of this force, but can I put this force somewhere else? It means I can I get this force somewhere else? It means I want to put this force in here. Can I do that? Yes, that is also possible. But how? See how it is done. It is done like I am going to put some force F, the same force like this F at this portion, at this position. Okay. And then I am going to put the same force in the opposite direction. F in this direction. Now this direction, the forces will nullify each other, and that is why I can say that this force is actually zero force. Okay, there is no effect of this force at this point because both of the forces are cancelling each other. So that is why I can say that there is no force in here, but actually we have transferred this force. Now forget about this one. Forget about this one. See, this force and this force, if you take, then they are just trying to produce a couple between these two. It means at this point this force F is there, then this force and this force is producing a couple, and there should be a moment. It means this force is getting converted into a moment, and that moment should be equal to force into distance. That means now we can say, instead of this and this, what we can write is the body was like this, the force is like this, and at this point there is a moment like this, and that moment, instead of this there is a moment, and that moment is, this is the distance, perpendicular distance between these two. Perpendicular means at 90 degree angle. 90 degree angle, this is the distance, this is the 90 degree angle, and this is the distance between these two. So this moment is equal to force into distance. Okay. Now we have converted this force, we have placed, instead of here, we have placed this force in here. Okay. Okay, so now this is how we can transfer a force from one position to another position. We can just get this force in here and then a moment. So next, what about so many forces? If there are number of forces, then if there are number of forces, that means suppose one force is acting like this only. This is F1. Another force is acting like this, F2. Another force is acting like this, F3. Okay. Now I want all this force to act at a single point. See, can I do that? I want all this force to act in here at point O. This is the point O where I want these forces to act. We can convert this force like this. See, first one, we need to find the perpendicular distance. Okay, see, this one is D1. This distance is suppose D2, and I am putting this force in here, and this distance is D3. So here is the force 3 now. Here is the force 2 now, and here is the force 1 now. Okay, so all these forces are going to give you, this is the force, this is the force, this is the force, but what we want is, we want these forces to act in here at this point, right? So we need to add the moment also. The moment due to this force, the moment due to this force, the moment due to this force. Okay, all these forces. First moment is going to be due to this force. It is going to act at this point like this, M1, moment 1, and then the second force is going to act like this due to this force. The moment at this point is going to act like this, M2. The moment this force is going to act like this, M3, where M1 is equal to F1 into D1, M2 is equal to F2 D2, M3 is equal to F3 D3. Now it is okay. So we have got, due to these forces, we have got forces and also we have got moments. Now what I want to say, that if these forces, these three forces were there, then it had to have some resultant. I want this resultant to also shift to here at this portion. Okay, so maybe these three forces was having some resultant like this R. Now I want this resultant also shifted to this portion. So this is the new resultant. R new. Okay, and the distance between these two are also D. So the new resultant, it can be found, the location of the resultant can be found by this Varignon's theorem, that is our new resultant. Okay, so this may look like a little bit, what can I say, but after solving one or two questions, our concept will be clear. That means, how can I solve it? So far we have calculated the magnitude of the resultant and the direction of the resultant, but we didn't know at what point the resultant were active. Now with this theorem, we can also find what is the resultant, at what point it is acting, at where the resultants are acting. Okay, so how to find the resultant? First, our concept, same thing. R is going to root over summation of force in horizontal direction square plus force in vertical direction square, and theta is going to be tan inverse summation of F force in vertical by force in horizontal. Now new resultant, that is the location of the new resultant, is going to be M of resultant should be equal to summation of all the forces acting about O, summation of all the moments acting about O. Okay, so this resultant is R into D, so this is M0, so D is equal to summation of M0 by R. We have found the M0. The M0 is a moment of MO, that MO is the moment of all the forces about O, that is M1, M2, M3, summation of these three, and we have also found the resultant R. Now we can find the distance of the resultant D. How? With one question we can solve it and see. So I think you understood this one, and if you don't, then no problem. Actually, with one question you can understand. I think you have written these things, so now I'm playing. Say this question is something like, example, 1. Okay, this question is, there is a beam this beam is having some point loads. This is a point load 20 Newton. This is a point load 30 Newton, and there is one more point load but not perpendicular. This is 20 Newton at an angle of 60 degrees. 60 degrees with the 60 degrees with the horizontal. Okay, now he has given this distance 1 as 1.5 meter, this distance 1.5 meter, and this distance 3 meter, this distance 2 meter. Okay, he has asked what is the magnitude, direction and location of the resultant. So far we have seen magnitude and direction. In this question we will see the location of the resultant by using Varignon's theorem. So see, first we need to calculate what is the R resultant. Okay, so we know how to calculate R. First is summation of horizontal forces. Okay, and that is going to be only one horizontal force is there, because only 20 Newton force will be having some component in the horizontal direction in the negative x direction. 30 kilonewton, 20 kilonewton are that just at 90 degree angle. So that is why it will not have any component in the horizontal direction. Only force is this one. So what I can do is 20 cos 60 degree. It is only horizontal. Okay, and that is cos 60 degree is half. So that is going to be 10 Newton in negative x direction. In the negative x direction. So that is why this is going to be 20 cos 60 degree. Okay, cos 60 degree in the negative x direction. Okay, correct. And the second one, say cos 60 degree is half, na? But you can do it because you see it is not having the component in this direction, it is having component in this direction. So from the figure only I am writing negative 10 in negative x direction. In the second case, summation of FV, summation of all vertical forces. First one is 20 is directly acting vertically downward, that is 20. No need to write 20 sine 90 degree because sine 90 degree is 1, and because of that it will give 20. Then 30 plus 30 plus the component of this force in vertically downward direction. So also what I can do is, these are also negative. These are also negative. It is giving negative 20 in the first case, negative 20, negative 30 and negative 20 sine 60 degree. Okay, so together I have got this answer as negative 67.3 Newton. This much I have got. Okay, so what is the resultant? Resultant is going to be root over of these two, negative 10 square plus negative 67.3 square. Okay, so this is 68.06 Newton. Now what is the angle? Angle is one of the forces are acting downward. The vertical force is acting downward like this, and the horizontal force is acting in negative x direction like this. So our resultant is going to be like this. Okay, both are negative, so that is why it is in the third quadrant. So this is 10. Now I am not writing the negative because I have already taken the direction, and this is 67.3. So finally this one, I am replacing this force to this position 10. This one is theta, so tan theta is equal to, the height is this one, the base is this one. If this is the angle, then the opposite is height, and this is going to be the base. So 10 by 67.3. Theta is equal to tan inverse of that one. Tan inverse of that one, here the theta will give you an angle of 8.451 degree. This theta is actually 8.451 degree. If this is the theta, then 8.451 degree, then this one is going to be 90 minus 8.451, then it is going to be 81.55 degree. Okay, then what is the total angle? The total angle is like this, 180, this one is 180 degree plus 81.55. So this is the total angle is going to be 261.55 degree. Okay, so this is the angle with the positive x direction. First one. So the resultant is acting like this. After that, what we want is, what is the location of the resultant? So what we have found so far, we have found that the resultant, where is the resultant? Resultant of all these three forces will be acting somewhere like this. This is 68.06 Newton, and if this angle is 81.55, then this angle is also going to be 81.55 degrees. Okay, so we have found this angle, at which angle in here. So now what we need to find is at what distance from, suppose this is A, this is B, at what distance from support A the resultant is acting. That means this one. X. We need to find that X. Okay. Actually, this is our whole concept, because this part we have seen before. This is our new concept, and I am just assuming that it will act in this position, but it may not be true. We'll have to see at what point it is acting, what is the value of X. So I'm assuming, I'm taking this one to be acting in here. Okay, now I'll have to take all the moments of these three. Okay, about the point A. About the point A, the first moment is going to be 20 force of like this. This one is the force, and the perpendicular distance, not any distance, perpendicular distance with the force. The perpendicular distance is this one, is this load is perpendicular to the surface, and the distance is 1.5. The second one is plus, this is 30 into, this is 1.5, this is 1.5, that is 3, plus I cannot do 20 into this, 3 plus 3 is 6. I cannot do it. Why? Because this is not the perpendicular distance, because the 20 is acting at an angle of 60 degree. At an angle of 60 degree it is acting. So that is why we need to take the vertical component of the 20. The vertical component of the 20 is 20 sine 60 degree, 20 sine 60 degree. So now I can take 20 sine 60 degree is acting perpendicularly to the surface. It is like this. Okay, this is 20 sine 60 degree. Okay, so 20 sine 60 degrees multiplied by the distance. Now this is the perpendicular force into the distance is 1.53, that is 6 into 6 meters. Okay, and that should be equal to the resultant multiplied by the distance. We know the resultant. Is 68.06 Newton, but we cannot take it directly. Why? Because this is also not the perpendicular. This force is not perpendicular to the surface. So we'll have to take again the sine component of this force. The sine component is 68.06 sine 81.55 degrees. 60, so I'm writing 68.06 sine 81.55 degrees multiplied by the distance. Distance is x. Okay, now you can calculate this one. See, the other component of the forces, 20 has got another component in this direction horizontally. So this is 10. The 10 is acting like this, but it is meeting at A. It means it has no perpendicular distance from A. And also the component, the cos component of 68.06 Newton also don't have any distance from A. So moment is there, force is there. Force is maybe 10, maybe 68.06 cos 81.55 degree. The forces are there, but the distance from A of the forces are 0. So force into 0, the moment is 0 for this component. For this component, this is minus 10 Newton for this 20. This component has got perpendicular distance of 0. So that is why it is not producing any moment, and that is why it can be neglected. Same thing is happening in case of this force, the component, the horizontal component of this force. Only its vertical component is giving us some moment. So x is finally, this is 30, this is 90, and this one 20 sine 60 degree. I have found this answer as 103.92. Okay, and I have found this answer of this 68.06 sine 81.55 as 67.32. So I am writing it 67.32 multiplied by this. So this part is in here 67.32 into x equal to 20, that is 30, this part is 90, this part is 103.92. so x is equal to, what I have got is 223.92 divided by 67.321. Okay, and that is the answer. The answer is 3.32 meter. 3.32 meter from A. So this x is equal to 3.32 meter. Okay. So now with Varignon's theorem we have found the location of the resultant. So now everything is known. What is the resultant, at what angle it is acting, and what is the distance of the location of the resultant. Okay. So the next is what we know about. Now we know about moment. Okay, so not about only Varignon's theorem. From the moment also there can be some questions can be asked. Okay, so now we can see some questions on how we can use the moment to equate something to get the answer. Okay, so moment is actually force into distance, perpendicular distance, that we understood. So the next question I am only literally the example 2. This question is: a beam is hinged at A and supported by a vertical string as shown in the figure. There are pulleys C and D which are not having any friction. A vertical load W is attached to pulley D. Then what is the position of load P for which the beam will be horizontal? So let us see what is the question. He has given a beam. This is the beam, and here it is hinged. Here it is hinged. This beam can rotate down or up like this. It can go like this and go like that. Okay, so it can rotate. Now he has said that it is attached to a pulley, and in the figure he has given like this. then this is pulley C and this is D. Okay, and a load of W is attached with pulley D. So the load W is attached with pulley D. Okay, if this happens, then this will go down because of this load. This will go down. If this goes down, then this string will go down, then this one will rotate and this beam will move up. Okay, but he has also said that we can give a load somewhere. We can give a load somewhere in the beam. Suppose a load like this P in the beam. Okay, if there is no pulley, there is nothing, this part is not there, then due to only load P, this beam will move down. Okay, he wants this beam to not to go up and not to go down. Okay, he wants the beam to be horizontal, stable. It means he wants this beam to be in a stable equilibrium. At what point we should apply this P so that the beam remains horizontal? That is the question. Say this is the distance x. So this is the distance x. At x distance, if I give the load P, then it will not go down, not go up. Okay. So if I give this P in here, then what will happen? This will have a chance to go down. How? We can see from this question. Let us see. It means the x has got a perfect value, or because of which this P load will not cause the downward movement of this beam, and this pulley will not cause any upward movement of this beam for a particular value of x. That x value we need to find. See, if this is W, then from free body diagram what we can see, that this W will be equally divided between these two. One in here, one in here. Okay, this is W load, this is W by 2, this is W by 2. If this is W by 2 upward, then for balancing a load has got to come here, this also W by 2. Okay, if this is W by 2, then to balance this load also there should be a load in here. This is moving this way, this is moving this balancing like this. No, something is wrong. Something should be wrong. Let us see. Oh, I'm sorry. Actually, I've forgotten one more load, because see, if this happens, then a force is got to be like this to nullify the effect. Another force has got to be like this in W by 2 in here. To nullify this effect also in here, one more force should be in here, that should be W by 2. Okay, so this is final W by 2 which is acting upward, and this is the P which is acting downward. It should be balanced. So finally what we have got? Finally we have got this beam like this, one force is acting like this, W by 2, another force is acting like this, P, and P is at a distance of x, and this one is at a distance of L. Okay, so now this is the hinge portion. Now what we can say is P multiplied to, for this to be in static equilibrium, the P into x, the moment like which is working like this, P multiplied by x should be equal to, this one is giving some clockwise moment and this one is giving some anti-clockwise moment. Okay, these two moments should be equal. If these two are equal, then only it is possible that this beam will be horizontal. So upward is W by 2 into, it means anti-clockwise is W by 2 into L. About, we are taking the moment about this hinged portion. Say this portion is A, this portion is A. So we are taking moment about A. P, the force into distance, force is P and distance from A is x, the force is W by 2, distance from A is L. So x is equal to WL by 2P. This is the final answer. If the x is exactly that one, then it will be in equilibrium. If the x is more than WL by 2P, then what will happen? If this x is more, that means P is shifting right side, in the right side. So P is somewhere in here. If it is in here, then beam will go down. Beam move downwards. And if x is less than WL by 2P, then opposite thing will happen. Beam move upwards. So this is the answer. Now the next question. See, this next question is very important because similar kind of question was asked in GATE exam in last year only, in 2018. So, example 3. Okay, there are two cases. Write down the question. A uniform wheel of 0.5 meter diameter and weight 1.5 kilonewton is resting against a rectangular block of height 0.2 meter as shown in the figure. He has given some figure. It is to be pulled over the block by a force P as shown in the figure. Find the force P which is required to roll the wheel over the block. It means we will have to find the minimum force which will be required. See how, see the figure. He has given a figure like this. This is the center. Okay. He has given this height as 0.2 meter. 0.2 meter. And then there is a force. There is a force acting P. P force is acting, and that should be the minimum. What is the minimum to minimum force? That means P minimum, for which will cause the wheel to move up this block, move over this block. And he has given the diameter phi of the wheel 0.5 meter. 0.5 meter is the diameter of the wheel. Okay. Now he has asked another thing. He has given that the weight of this wheel is 1.5 kilonewton. Okay. Now what we need to see is, in this question, if we find this kind of question, then we just need to equate the moments. Okay. By equating the moments only, these questions will get solved. Moment is force into distance. So there are only two forces. One force is P, by which we are pulling this block, and another force is the weight of this wheel. Okay. Now I'm taking some point. I'm writing this one as A. This is the point A. Okay. This is the point O. I'm writing this is the point O. This one is the radius, right now. If this is the diameter, then the radius will be half of this. So radius is this one is 0.25 meter. 0.25 meter is the radius. Okay. I'm drawing a triangle now. What is the use of this triangle? Let us see. Just give some name. B, and this is N. Okay. Now N is this point. N is this point. Now we just need to equate the moment. So we can say P minimum multiplied by, this is the force, multiplied by, we are taking the moment about point A. First of all, taking the moment about point A. What is the meaning of taking the moment about point A? It means we are taking the perpendicular distance of the forces from A. From A, what is the perpendicular distance of these two forces? One force, one force. One perpendicular distance is from A. This is this one. Okay. Another one is this one. These are the two perpendicular distance. For P minimum, I am writing it as B1. For 1.5, it is AB. AB. Perpendicular force means which is at a 90-degree angle. It means this angle at we are measuring the distance of A from P minimum, and that force should be at a right angle, at a 90-degree angle from the from where it is measured. It means we cannot measure the distance like this. This distance from A, that is not correct. Okay, only the 90-degree angle is correct. Here also we are measuring this distance. This is the distance and AB, that is 90 degree, or this is also 90 degree. So first of all we need to find what is the D1 and what is the AB. Okay, so first of all we can write P minimum into the moment D1 is equal to 1.5 into the distance AB. How? Because we have equated the moments. Two forces are there and their moments should be same. One is not letting it go up and another is trying to move it over the block. Okay. When the two forces will be equal, or this force will be just a little bit more than this, the moment of this will be equal to a little bit more than the moment produced by this, then only it will move over the block. So that is why I am trying to find what is the P minimum, that is exactly that point where it will start moving up. Okay, or a little bit more, 0.0001 more than P minimum will cause the block to move over this, this wheel to move over the block. Okay, so now P minimum into D1. D1 is what? Easy. See, if this is OB, this one is OB. Okay, so what is OB? OB is equal to ON. This is the ON. This height is ON. ON minus the height of the block minus 0.2. See from the figure, OB, this much, is equal to this ON minus this part. This one is the block. So ON, what is ON? ON is the radius of the wheel. Diameter is given. Radius is OB is equal to 0. This is ON is 0.25 minus 0.2 is equal to 0.05 meter. What is OA? OA is directly, it is, if this is the radius, this is also radius. So this is the radius 0.25 meter. Okay. Then AB is equal to root over of OA square minus OB square, and this is going to be equal to 0.245 meter. So AB is 0.245 meter. What is D1? D1 is the radius, this one, 0.25 meter, plus this one, 0.05 meter. Okay, so D1 is equal to 0.25 meter plus 0.05 meter. So that is 0.3 meter. D1 is 0.3 meter. Okay. Now everything we have found, directly we can calculate P minimum multiplied by D1, 0.3 should be equal to 1.5 multiplied by 0.245. So P minimum is equal to 1.5 into 0.245 divided by 0.245. 3. So that is going to be the answer 1.225 Newton. So this is the answer, 1.225 Newton. It means if you pull this with a little bit more than 1.225 Newton, maybe 1.2255 or 1.226 Newton, then this will easily move over the block. So this is the answer. Next one is example 4. So this is the last question for today. This question was asked in GATE 2018. GATE 18 Civil Set 1, 2 marks. This question is, I am only reading. A cylinder of radius 250 millimeter and the weight of the cylinder is 10 kilonewton is to be rolled up an obstacle of height 50 millimeter by applying a horizontal force P at its center as shown. What is the minimum value of P? What is the minimum value of P? The answer are given: A 4.5 kilonewton, B 5 kilonewton, C 6 kilonewton, D 7.5 kilonewton. So these are the 4 options given. What is the difference between the last question which we have solved and this question? The only thing is where we are giving the force, okay, where we are pulling. In the last case, the wheel was adjusted with the top, with the rope, and in this case it is at the rope is pulling from its center. The force is applying. We have applied the horizontal force P at its center of the wheel. So this is the only difference. He has given that the radius, now again don't do mistake, okay. In the last question he was given the diameter, in this case radius. So the radius is now 250 millimeter, and the height of the block he has given as, this one is 50 millimeters, 50 millimeter and 250 millimeter. So this is also 250 millimeter. Okay. Now this one, this is center. From here, this is 250 millimeter. This is say the point A. Okay. The force is applied in this case is at its center. like this, then this should be P minimum. Whatever it is, this should be P minimum. Okay. So to do this again, we can do our whatever we have seen. And another thing is what is stopping this wheel to move up, that is its own weight. Its own weight is acting in here, and that own weight is 10 kilonewton. 10 kilonewton is the weight. Okay. So what is the perpendicular distance? This is the perpendicular distance. Okay. I am drawing the triangle in here. This is say O and this is B. AB. Say this is also the distance AB. So this distance is 250. This distance is the OB. If I'm writing here N, this point is N, so ON is equal to the radius 250 and height of the block. This height of the block is, height of the block means this portion, this one. Height of the block is this one. BN is 50. So what is OB? OB is this portion. This portion is 250 minus 50, that is 200 millimeter. 200 millimeter is the OB. So what is AB? AB is equal to root over of OA square minus OB square. See, this is hypotenuse and this is the height. Okay. So this is the base. AB is actually OA square minus OB square. So this is actually OA square is how much? OA square is 250. 250 square minus OB square is 200 square. 200. This is 250. This is 200 square. So AB is 250 square minus 200 square is 150. 250 square minus 200 square is 150 millimeter. This is 150 millimeter. Okay. So now we can we have found the force P. We need to find the force P. So for taking the moment about A, taking the moment about A. What does it mean? Taking the moment about A? It means what is the perpendicular distance of the two forces up from A. From A, the 10 kilonewton force is acting at a distance of AB. AB is 150 and P is P minimum, that is this distance, and this distance is OB. OB is 200, so this is 200. Okay, so force into perpendicular distance, P min into OB should be equal to 10 into 10 kilonewton acting downward into the perpendicular distance. The force is 10 kilonewton, the perpendicular distance AB. So P min is equal to 10 into AB. AB is what? 150 divided by OB. OB is 200. So that is, the dimension is kilonewton into millimeter divided by millimeter. So millimeter cancel. Only kilonewton is left. 10 into 150 divided by 200 is 7.5 kilonewton. 7.5 kilonewton. So this is the answer. So which option is correct? Option D. Option D is absolutely correct. I hope you can understand. So thank you. This much is for today, and in the next day we'll start truss analysis. Okay. So I think this will be helpful because structural analysis has also got truss, but that is advanced. From we'll learn the basic of trusses. So that will be, I hope that will be helpful for you. So for today, this much is. Thank you.